Welcome to the third video of the training series related to the creation of user-defined fluids in SSP. In this video, we will look at how to create a glide fluid, which is a mixture of two or more substances. Non-azeotropic or glide refrigerants are mixtures where the components have different saturation temperatures at the same pressure level. This is a typical example of how a non-glide and glide refrigerants look in pH plots. The properties required are very similar to the non-glide fluid, which was described in the earlier video, except the pressures. Here we need to have dew pressure and bubble pressure in addition. The mixture that I have selected to demo is R407H, in which 3 refrigerants are mixed in a proportion as shown. Let's see how we define a new mixture in RefProp. Add all the components in the right hand side and then click OK. Enable the mixing ratio by mole fraction or mass fraction depending on what is known. Here I choose mass fraction. Enter those values in the fields. Verify the sum above shows 1. Add or modify the name for the mixture. We can store the mixture in the RefProp defined path. If ever there is an error popping up while making a mixture, it shows it's not able to calculate based on the default calculation settings. For that, we need to modify the calculation settings to point to Peng-Robinson cubic equation of state for all the calculations as shown. It's advised to reset it back to normal settings for any other calculations. The procedure for selecting units and list of properties have been already discussed in the previous video. Please refer that before continuing. Select the right fluid. Now let's see the fluid information from RefProp. It will give us molecular weight, mass fraction, critical property values, etc. Here we need to supply the temperature range to extract the data for the saturation table. To get the minimum temperature, we need to take a low pressure of 10 kPa as shown in the pH diagram and calculate the corresponding saturation temperature. So we get around minus 83.46 Celsius. And for getting the maximum temperature, it is advised not to go closer to the critical temperature in order to get a good curve fit. So if the critical temperature is 86 degrees Celsius, we will choose somewhere close to 80 degrees Celsius as max temperature. In order to produce a saturation table, we need to update the fields as shown. Now we will process the data from RefProp in the following order. First, we will collect the data in the format required by the fluid editor. Process it in an Excel sheet. Especially the latent heat needs to be processed as difference of enthalpies of vapor and liquid. Modify and match the units of Excel data with the fluid editor in order. Copy and paste the Excel data into the grid of the fluid editor. Fill in the necessary fields. We can also check the quality of the curve fits using the plot data button. Fluid can now be exported to SSP by clicking the S symbol button, and this file will go and sit in the local database file fluids.xml. This can be further verified by checking in SSP under My Fluid category. Users can also download and save the individual data.xml file to any location in their machine using down arrow symbol. And this file can be shared with other SSP users to import into their machines. Typically, this file will be named after the fluid name such as isobutene.xml or R407.xml, etc. We hope this video was helpful. Thank you.